This lesson is for Statistics, Day 5, Types of Statistical Studies. So this is a very different kind of lesson. There's going to be a lot of reading and discussing type of things, not the number crunching that we're used to. So it would be helpful if you had a highlighter handy if you're going through this with the notes, so that you can highlight the main points as we go through here. A lot of vocabulary and things of that nature. So types of statistical studies. So we're going to start with looking at, again, some different studies that we can do, starting with what's called an observational study. So when you're doing an observational study, of course, the idea is that you're just observing your subjects and recording the data. It says no treatment is imposed by the observer. Which means that the person that's running the study is not actually creating anything for anyone to do. They're just observing what's already happening. So, for example, researchers investigated the link between the use of cell phones and brain cancer. There are two variables in the study. One is the extent of cell phone usage, and the second is whether a person has brain cancer. Both variables were measured for a group of people. This is an observational study. There was no attempt to influence people's cell phone usage to see if different levels of usage made any difference in whether or not a person developed brain cancer. So, yeah, they weren't doing anything with the people, they were just observing what happened. That's what makes it an observational study. A survey is a particular type of observational study. I'm sure you've completed a survey at some point or another in your life. So a type of observational study says data is collected from a series of questions. So we have an example of a survey here. It says, what kind of computer do you own, Dell or Mac? Now, this isn't really the best survey because, what happens if you were taking the survey and you didn't have a computer? Or what happens if you had a different brand of computer? So when you're designing these things, there's a real science to it, a way to design your survey and ask your questions so that you can actually get useful information. So a better way to do this would be to ask, do you own a computer? Start with that. And then if so, what kind of computer is it that you have? And you're likely to get better information that way. So yeah, designing the survey in a way to get good information is a thing. Okay, census is a survey given to an entire population. You may have heard the term census. They do the census in the United States every 10 years. When they go around basically to everyone's house and try to count up everybody that lives in the country. So that's the census. And again, the idea is it's the entire population when that keyword census is there. So we're going to talk about the idea of bias in our statistical studies, which is a very important thing to be aware of. Bias is when certain individuals are more likely to be selected from a sample. So if you get to the point where certain people are more likely to be picked, than others, then you've got a problem with your results. It causes the results to be unreliable. If the sample is not representative of the entire population. So having bias in your statistical study is bad. It means that whatever results you get may not actually be true, and you wouldn't want to be making any conclusions based on that. So we have an example of a type of question that you might be asked on the Regents that has to deal with this. It says the yearbook staff has designed a survey to learn student opinions on how the yearbook could be improved this year. If they want to distribute this survey to 100 students and obtain the most reliable data, they should give the survey to, it says every third student sent to the office, every third student to enter the library, every third student to enter the gym for a basketball game, or every third student arriving at school in the morning. So when we are designing a survey like this, we want it to be as random as possible. Okay, so we're looking for which one of these would give us the most random sample. So if you think about that for a moment and say which one's going to give us the most random collection of kids to answer the survey, hopefully you landed on this one, choice 4. right? We say every third student sent to the office. Well, if you're getting sent to the office, you probably have some sort of issue, so that's not necessarily random. Every third student to enter the library, and there's a commonality there. Every third student to enter the gym for the basketball game, same thing. But every third student arriving at school in the morning, say out of all these choices, this is the most random that you would get. And the more random it is, the less bias you have, and that's going to make your study be better. So random selection, right, very important to observational studies so that we can reduce bias, so that the results can be generalized to an entire population. So you can actually take the results of your study and then say something about it. On to the next page, another type of statistical study is an experiment. So when you are doing an experiment, that's when you're actually imposing a treatment. Okay, a treatment is something that you're actually asking your subjects to do, or you're doing something to the subjects in your experiment. Okay, so assign subjects to treatments to see the effect the treatment has on the response variable, and can include cause and effect. Okay, so the treatment is what is done to the subjects. The response variable is the variable that's being measured in the study or the experiment. So we're going to look at a couple examples here. Erase my random highlight. It says, for each of the following study descriptions, identify whether the study is observational study, survey, or experiment. Give a reason. For observational studies, identify the population of interest. And for experiments, identify the treatment and the response variables. So letter A says, a study investigated whether boys are quicker at learning video games than girls. 20 randomly selected boys and 20 randomly selected girls were given a game to play that they had never played before. The time it took them to reach a certain level of expertise was recorded. So the question is this an observational study or is it an experiment? You're asking yourself, well, was something actually done to the people in the study, right? And the answer is yes, right? Because they were given a game to play, right? That's the treatment. And then the time it took them to reach a certain level of expertise was recorded. That's the response variable. Okay, so I would say this is an experiment, right, because something was actually done or asked of the people, right? So the treatment was playing a new video game. Treatment, playing a new video game. And the response variable is what they were studying. Oops, there's that update again. Okay, so the response variable, the time it took to reach a certain level. Okay, moving on to letter B. For your statistics project, you collect data by posting 5 questions on poster board around your classroom and recording how your classmates respond to them. So is this an observational study or is this an experiment? Was there some sort of treatment imposed? The answer here is no. There's no treatment imposed. You were just asking people to answer some questions. So this is an observational study. Observational study. It's actually a survey. You could also call it a census too. It just depends on what you're measuring, right? So it's a survey if you consider the population to be all of the students in the school. Right? So you're saying, I want to do a survey of all the students in the school. I'm going to take a sample of that and survey my class. Or if the census, since the census means the entire population, if your whole point was just to study your class, then when you just talk to the people in your class, that's the entire population, so it's a census. But it's the observational study is the key there. No treatment imposed and just collecting data. Okay, letter C says, a professional sports team traded its best player. The local television station wanted to find out what the fans thought of the trade. At the beginning of the evening news program, they asked viewers to call one number if they favored the trade and a different number if they were opposed to the trade. At the end of the news program, they announced that 53.7% of callers favored the trade. So is this an observational study or is this an experiment? Was there some sort of treatment imposed? the answer there would be no. We were just collecting data without actually doing anything, so this is an observational study. Here's another example of an observational study, another example of a survey. Right? The population that they were looking at was the fans of the team, right? All fans of team. Now, it's worth noting that this is actually a really bad technique for doing a survey. If we go back to what we were talking about, bias and making sure that we're having people randomly in our survey, right? When you set up something like this that's on a volunteer basis, it's really not random at that point, right? Because think about it, if you're sitting on your couch at home and you don't really care about what happened with the trade, you're not going to bother to call into the news station. However, if you have a really strong opinion about it, right, then you're going to call up. So it's not really random, not really representative of the entire population. So not a great technique to have something where only volunteers are answering your questions. You'd want to find a way to make it more random than that. Okay, and then letter D says, a study determines whether taking aspirin regularly helps to prevent heart attacks. A large group of male physicians and comparable health were randomly assigned equally to taking an aspirin every day or to taking a placebo. If you're not familiar with the term placebo, that's like fake medicine basically, but then you don't know whether you're taking the fake medicine or the real medicine. So that's how they can study and get a good answer, a conclusion from their data. Right, after several years, the proportion of the males who had suffered heart attacks in each group was compared. So you say, is this an observational study or is this an experiment? Was there some treatment imposed? Yes, there's definitely a treatment imposed, right? Because they were asking them to take aspirin again, or the fake aspirin. So this is an experiment. Right, the treatment that was imposed was either taking aspirin or the placebo. And then the response variable, what they were actually studying, and they were trying to figure out if aspirin had an effect on the number of heart attacks, right? So really they were studying whether someone had a heart attack or not, which is not particularly pleasant to talk about, but that's what they were studying, right? So have heart attack or not, that's the response variable. Okay, but again, they actually doing something with the people in the study, imposing a treatment, that's what makes it an experiment. So moving on to talk a little bit more about this idea of random assignment, which is a very important idea when you're designing observational studies and experiments. So random assignment used in experiments to assign subjects to treatments, and it creates comparable treatment groups. So right out of the gate, you're not going to have bias one way or another. So the biggest thing to know about random assignment is, again, whenever you are designing an experiment of any kind, right? So when designing experiments, you must have random assignment. So random assignment must be involved in how you set up your experiment for it to be considered a good experiment with conclusions that can actually be used. So how do we actually do this when we're setting up an experiment? There's a couple of ways. So it says you must randomly select 2 students from your math class of 21 people. We will use the random digit table to select these students. So this is one way that you can pick a couple of people from the class and be truly random about it. So this is just a table just of a bunch of random numbers. Again, where do these random numbers come from? You can use your calculator, right? Or you could do it on a computer. So use calculator or computer to produce the random digits. So you just have this big list of completely random numbers, random digits between 0 and 9 from the calculator or the computer. Another way to make it even more random is when I show you what we're going to do in a second. You can start in any row. You can use any row, which makes it even more random. So now you're adding another level of random on top of the randomness of the random numbers. So the way that we're going to use this to pick 2 people out of our class of 21 people is we're going to number the students in the class. Because we've got 21 people, which means we need 2 digits. So we're going to number them from 00 to 20, right, which will actually be 21 numbers in the end because we're counting 0 as 1. And then we're going to move through our random digit table and we're going to pick 2-digit numbers in this range. As we go through and do our selections, we're just going to discard any numbers that are greater than 20, because we only have 21 people in the class, or numbers that we picked already, numbers already chosen. And so we're going to number them from 0 to 20, which will give us 21 numbers. We're going to pick 2-digit numbers in this range and discard any that are greater than 20 or numbers that we chose already. Numbers already chosen. So I'm going to move through my random digit table here, and I'm looking for 2-digit numbers that are between 0 and 20. So the first number, the 2 digits together, would be the number 66. So that's too large for what we're talking about, so we can cross that out. The next 2-digit number would be 72. Again, that's too big. The next 2-digit number would be 80. That's too big. The next 2-digit number would be 8. Okay, there we've got a winner, right? So student 8 is the first student that we select, whoever got assigned that. Okay, the next 2-digit number would be 40. That's too large. The next 2-digit number would be 4. And that works. That's in our range. Okay, so now we've got 2 students, right? So whoever was number 8 and number 4, those are the 2 that we randomly selected. But we could have started in any row and got 2 different random students. So this is completely random. There is no bias in here whatsoever. That's the way you want to design your experiments. Here's another example of doing random assignment down here at the bottom. What are the identification numbers for 10 students chosen at random from a population of 78 students based on the following string of random digits? Start at the left. So instead of a table, I've just got one big long list of random digits from 0 to 9, right? I need to select 10 numbers for my 10 students. 78 people altogether that I'm choosing from. So I'm going to number them from 00 up through 77. So yeah, I'm going to work my way across and keep picking 2-digit numbers in that range until I've got all 10 numbers, crossing out any that I've used already or if they're too large. So again, I'm looking to get 10 numbers, and I'm just going to start working my way across the table. So the first 2 digits is 27. That works. Okay, so whoever number 27 will get picked. The next 2 is 81. That's too large, so I'm going to cross that out. Okay, 67's up next. That's good. So person 67 gets chosen. Next one's 84. Too large. The next one is 16. That's good. So I'll take 16. The next one is 01. Also good. That's in our range. The next one is 82. Right, that's too big, so we'll cross that out. The next one is 27, which is in range, but that's actually a repeat. We already got 27. Repeat. So I don't want to get 27 again. Okay, that brings us to 35. 35 is good, so we'll take 35. The next one is 21. That one's okay, so we'll take that person. The next one is 37. That's good. Okay, going until I get 10. 1, 2, 3, 4, 5, 6. I got 7 right now, so a few more. Okay, 74 is okay, in between 0 and 77, so we'll take 74. 10 is okay, so we can get that one. The next one up is 16, but we've actually got 16 already, so I have to skip that one. And then the next one is 31. That's good. And then I think that's our last one. Okay, so now we've got our 10 people, right, from the 77 people, and we chose them completely randomly. Okay, so random assignment when you're designing your experiments is important. Okay, next thing that we're going to discuss here is cause and effect versus correlation, right? Correlation meaning a relationship between two things. So how do you figure out if there is actually a relationship and if one thing caused another thing? So we have a little story here. In the new suburb of Awesomport, housing developments, shopping centers, and schools are all being built. It is the best new town to move to. However, the local news station just came up with a story that the number of speeding tickets have tripled in this town last year. That is not good news. Okay, the news station also reported that the number of students graduating from Awesomport also tripled. Now that is good news. Since both of those things increased at the same rate last year, the news reporter then concluded that people should start speeding in their town if they want graduation numbers to increase. The next night, there were numerous speeding tickets in school as Toughville. Okay, so they're saying that more speeding tickets, more graduating students, one thing caused the other. So if you want more kids to graduate, you should start speeding in your town, right? Does this make sense? Because that's what they're concluding from the data. Okay, hopefully you're saying, nope, don't think that's related. That was probably just a coincidence. And that's the big idea here. So there does appear to be a correlation. They both tripled at the same rate. However, is one thing affecting another thing? In this case, probably not. Okay, so in big letters, big bold letters, correlation does not imply causation. Right? Just because there seems to be a link between two things does not mean that we can say that that is necessarily true. The only way that we can prove that that's true, the only way we can determine cause and effect legitimately is by doing an experiment. Okay, so just noticing that something is happening, you cannot conclude that one thing is causing another. You must design an experiment to actually prove that that is happening. Okay, so number 5 says, suppose an observational study establishes a link between asbestos exposure and lung cancer. Based on that finding, can we conclude that asbestos exposure causes lung cancer? Why or why not? I mean, it makes sense that being exposed to asbestos would cause lung cancer. However, the fact that they were only doing an observational study means that we cannot actually conclude that. Right? We are not allowed to say that asbestos exposure causes lung cancer. This was an observational study only. So observational study only, meaning that no experiment was actually done. Okay, so there is a correlation, but you cannot prove that one thing caused another thing unless you actually do an experiment. On to letter B. Ice cream sales and the number of drowning accidents are positively correlated, meaning they're both going up at the same rate. Therefore, can it be concluded that ice cream sales cause drowning? What else could be affecting these two variables? So hopefully you're saying, no, don't think ice cream is causing more people to drown. But what else could be going on that would affect both of those things to be going up? So ice cream sales are probably going to go up when the weather's warmer, right? People go swimming more in the summer. So there's a good chance that when they did this study, it was summertime. And then they found that both ice cream sales and the drowning accidents went up. But that's just a coincidence that they both happen to be going up. That was really affected by, another outside source, the fact that it was the weather, right? So it could be the weather. In the summer, I'll say more ice cream sales and more swimming. And unfortunately, if there's more people going swimming, that would mean that there might be more people that are drowning. Not that we should joke about that, but yeah, the fact that they are both going up at the same rate does not mean that one thing was causing another thing. There could be something else going on. Okay, so correlation does not imply causation. You got to have an experiment. Okay, last thing to discuss here is population characteristics and sample statistics. So the keyword population, right, refers to the entire set of subjects that we're interested in. So say I want to say something about our entire school, then I'd say the population is our entire school. A population characteristic then, it's a summary measure calculated using the entire population. So if I talk about the average age of the entire school, that's a population characteristic because it's a measure that deals with the population at large. Related to that, we then talk about a sample. So a sample is a subset or a part of the population that's being observed. So say I want to talk about our entire class, but I focus on just 5 students from the class. So those 5 students are a sample. So then a sample statistic is a summary measure calculated from a random sample. So if I take those 5 students and I average their age, because that's related to a sample from the population at large, that's called the sample statistic. Okay, so population is everybody all together, sample is just a piece of it. So the number 6 says, for each of the following, does the group described constitute a population or a sample, or could it be considered to be either a population or a sample? Explain your answer. You know, some of these you really can argue them one way or another. We're just trying to get the idea of the difference between a population and a sample. So letter A says the animals that live in Yellowstone National Park. So the way they sort of have that set up, it would assume that they're talking about the population, right? All the animals that live in Yellowstone National Park. However, what if we were discussing all the animals in the United States? In which case, that would just be a sample, right? So sample, if we're studying all the animals in the U.S. All right, so if we want to study all the animals in the United States and we're just looking at the animals in Yellowstone National Park, it's a sample. All right, but if we were just interested in the ones in Yellowstone National Park and we did all of them, then it's the population. Okay, letter B says some cars on the lot of the local car dealer. So some cars out of all the cars, that's a sample for sure. Letter C says the words of the Gettysburg Address. Again, they're implying that all of the Gettysburg Address, your entire population is what we're talking about. And if we were saying all the words in the English language and we were looking at the words in the Gettysburg Address, then you could argue that it's a sample. But just based on this information alone, it's worded to sort of imply that it's the population. Okay, so then number 7 says, are these population characteristics or sample statistics? So suppose the population of interest is the words of the Gettysburg Address. There are 269 of them, depending on the version. So then when letter A says the proportion of nouns in all the words of the Gettysburg Address, right, if the population is all the words in the Gettysburg Address, and we're looking at all the words in the Gettysburg Address, and we get some statistic out of that, that's a population characteristic, right? So it's a measurement of the entire population as a whole. Population characteristic. But then in letter B, when it says the proportion of nouns or the proportion of words containing the letter E in a random sample of words taken from the Gettysburg Address. So now we're taking a sample from our population and getting some measurement out of that. That's then a sample statistic. Because we just took a sample and studied that. Letter C says the proportion of all words in the Gettysburg Address that contain the letter E. So yeah, we're going back to all words in the Gettysburg Address. That's what's defined as our population. So that's a population characteristic. Okay, and then just one last thing over here on the last page is the idea of a representative sample. So in an observational study, just as in surveys, the people or objects to be observed would ideally be selected at random from a population of interest. Right? So if we want to get a good sample, we want them to be selected at random. This would eliminate bias and make it possible to generalize from the sample to the population. So for example, to determine if the potato chips made in a factory contain the desired amount of salt, a sample of chips would be selected randomly so that the sample can be considered to be representative of the population of chips. All right, so we randomly test potato chips that are being produced, make sure they're okay, and as long as we're doing that randomly, we can assume then by and large that all of the chips that are being produced are okay. But we have to make sure we're being very random about it. And if so, then it's going to be a representative sample. Okay, so this last little bit says, will these scenarios yield a representative sample, and explain? So it says, poll everyone in your friend's math class about their opinion of weighted grades. So asking the people in one math class and having that be representative of the entire school population, say, what they think about weighted grades, you know, hopefully you're maybe thinking no on that, right? Because again, just one math class is not representative of the entire school. Not representative of the whole school. You know, what exactly is this math class? Is it an honors class? Is it an AP class? Is it a Regents class? Right, so just asking one class of people and getting their idea about weighted grades, that's not going to give you a good idea of what the school population at large thinks about it. So that would not be a good representative sample. Letter B says, assign every student in the senior class a number from 1 to 314, then use a random number generator to select 30 students to poll. Okay, so we're really using our random selection here. That's going to give us a good representative sample. Again, because we are randomly selecting our people that we're asking. Okay, so the more random it is, the more representative it's going to be of the whole population. And then finally, letter C says, ask each student that's going through the lunch line in the cafeteria who they will vote for. Again, sort of random. I would argue maybe not the best way to be representative of the whole school, right? These are only the students who buy lunch. So there might be some commonality there. There is better ways to get a representative sample of the whole school. So going back to this randomly selected idea. Okay, that's the end of statistics, day 5.